Okay. Example 1. Your parents tell you that if you earn a minimum grade of an A minus in this course, they'll reward you by depositing in your account $500 next year, $1,000 the following year, and $2,000 the year after that. If you can earn an annual return of 6%, how much would you have in your account immediately after your parents' last deposit? Part B. If your parents can earn 8% per year, what size one-time deposit would they have to make today so that they will be able to keep their promise? In other words, they want to come up with the same net future value in 3 years. Okay, let's do this. Example 1. Okay, so we're gonna draw the timeline first, and it looks like this. So they'll deposit $500 next year, so 1 year from now, $1,000 the following year, and $2,000 the year after that. Okay, and you can earn an annual rate of return of 6%. So R is 6%. And I want to clearly indicate what you're solving for. It says, how much would you have in your account immediately after your parents' last deposit? The last deposit occurs in year 3, so we want to solve for the net future value as of year 3. Okay, so this is a multiple cash flow example, but it doesn't fall into any patterns that we talked about. So it's not an annuity or a perpetuity. So this one doesn't have a pattern. So we're gonna calculate the future values of each of these cash flows individually into time $3. Okay, and we'll just add them up. Okay, so if I were to write a formula, then the future value as of year 3 of this entire thing is, I'll take the future value as of time 3 of the cash flow that occurs in time 1, future value of year 3 of the cash flow that occurs in year 2. We'll take the future value as of year 3 of the cash flow that occurs in year 3. Okay? So to show you this more clearly, the 500 is the cash flow that occurs in year 1. The $1,000 is the cash flow that occurs in year 2. And the $2,000 is the cash flow that occurs in year 3. Okay? So we're gonna use the future value formula to get the year 3 value of all of these cash flows. So we have 500 times 1.06, 1 plus r to the second power. Okay, so here we're using the future value formula, this formula. Okay, and just to make sure, the n here is 2 because we're going from time 1 to time 3. Okay, so the green cash flow, we'll do something similar. 1000 times 1.06 to the first power. Again, here n is 1 because we're going from time 2 to time 3. Okay, 1 compounding period. And the last cash flow is $2,000. So the third cash flow, the $2,000, we don't do anything with it because it's already expressed in time $3. It already occurs in year 3. Okay, so we just add everything up, and the answer is $3,621.80. This is the answer. This is how much you would have in your account immediately after your parents' last deposit. Okay? So, we'll do the second part. It says, if your parents can earn 8% per year, what size one-time deposit would they have to make today so that they will be able to keep their promise? Okay. So, their promise is basically this. They're gonna have this much in your account in year 3. Okay? So if I were to draw the timeline again, now in year 3, the goal is to have this much in your account. Okay? And we have a new rate of return. Your parents can earn an 8% return per year. Okay? And we're trying to solve for how much did they have to put in today at a rate of 8% return so they can reach this amount in 3 years. Okay? So we're going to use the PV formula. PV equals future value divided by 1 plus R to the nth power. The future value is 3621.80. 1.08 raised to the third power. Okay? So this is 3 because from year 3 to time 0, there are 3 discounting periods. Okay? And the answer is 2875.10.